In this video, we're going to start the next section, 5.4, and we're going to see some new formulas here, the sum and the difference formulas. There's only one bullet point for this section. Use the sum and difference formulas to evaluate the trig functions, verify identities, and solve trig equations. All right. Here are the sum and difference formulas, and look at the patterns. For here, the first two are the sign functions, the sign of a sum and the sign of a difference. And look at the pattern for sine. Over here on the other side, we have sine cos plus cos sine. So the pattern is sine and cos, and then it reverses to cos and sine. And we're doing the sign of a sum, so the formula also has a sum in it. For sign of a difference, very similar. Again, the pattern is sine cos cosine, but since we're doing a sign of a difference, this has a minus sign in it, a subtraction. Now let's see how this changes when we move on to the cosine formulas. Cosine has a pattern of cos cos sine sine. So before in the sine one, we had alternating sine and cos, and then cos and sine. Here we have them bunched up on the same side. Now it's cos cos minus sine sine. When I should also point out, notice the pattern for the angles is always the same. Over here, U is the first angle, V is the second angle. Over here, it's always the first thing is a U and then a V. And then we have our plus or minus sign. On the other side, we again have U first and then V second. So again, cosine's pattern is cos cos sine sine, and here the sign will change. When we're doing the cosine of a sum, our formula has a minus in it, a difference. When we do cos of a difference, it's cos cos plus sine sine. Again, we're subtracting here cos of a difference. The sign switches when we jump into the formula. And then finally is tangent. Let's again look at the patterns. The numerator is tan and tan, and we are either adding or subtracting them. In tan of a sum, we're adding. Tan of a difference, we're subtracting. And then that sign will switch when we move to the denominator. Over here, it's a plus. Downstairs, now we'll have a 1 minus tan times tan. In the numerator, we're adding. Down here, we're multiplying and subtracting from 1. So in tan of a difference, the minus sign is the same in the numerator, tan minus tan, u minus v. Downstairs in the denominator, 1 plus their product, tan u times tan v. So there's the formulas. Let's take one of them out for a test drive here. Example 1 and 2 will show how these formulas enable us to find exact values of trig functions involving the sum or difference of special angles. On the unit circle, I call those our friendly angles, 0, pi over 6, pi over 4, pi over 3, pi over 2. Here is sine of pi over 12. And we want to find the exact value. We don't want to just punch this in a calculator and get a decimal, even if we only round it off to 10 places. We want an exact value, and this is how our math forefathers would have found this. Again, pi over 12 is not a friendly angle on the unit circle, but we could rewrite pi over 12 as pi over 3 minus pi over 4. That's supposed to be a 3. That's terrible. Let me back up. Pi over 3 minus pi over 4. Again, pi over 12 is not on the unit circle, but pi over 3 is, and pi over 4 is. So we're going to rewrite this sine of pi over 12 as the sine of pi over 3 minus pi over 4. Now we go to our formula. We're going to the sign of a difference formula. So this is the one we're going to use. Sign of a difference is sine cos minus cos sine. So we can write it like this. Sine times a cos minus cos, and then another sine. And then we're just going to drop our angles in there. This first one is always u, the second one is v. So here, these two get a pi over 3 first, and a pi over 4 next. And the second side, after the minus sign here, we use the same angles again. Pi over 3 goes in first, Pi over 4 goes in second. Notice we don't have a repeat. Here's sine of a third pi. Over here it's sine of a quarter pi. Here's cos of a quarter. On the other side is cos of a third. You'll never see a repeat like a cos of a quarter and a cos of a quarter. You've used the formula wrong. So now we go to the unit circle. Here, sine at pi over 3, that is root 3 over 2. This cos at pi over 4 is a root 2 over 2. We're going to multiply those. Here we're going to subtract. Cos at pi over 3 is a half. We're going to multiply that by the sine at a quarter pi. That's root 2 over 2. Now the beauty about these is that they will always get a nice common denominator on both sides of our minus or plus sign. So here, look, on the left, we have 2 times 2. Over here is 2 times 2. So our common denominator on this time will be a 4. And then our numerators, root 3 times root 2 will be a root 6. And then we're going to subtract. This 1 times root 2 is just root 2. So there's our final answer. The exact value of sine of a 12th pi is root 6 minus root 2, all divided by 4. Okay, there's one with a radian example. Here's one with degrees. We want to find the exact value of cosine of 75 degrees. And 75 degrees is not one of our friendly angles on the unit circle. But we can rewrite cosine of 75 as the cos of 30 plus 45. 30 is on the unit circle. It's one of our good angles. So is 45. So now we have a cos formula, and we're going to do the cosine of a sum. Back up to here. Here is cos of a sum. Now the pattern changes to cos cos, and the sign will flip to a minus. Cos cos minus sine sine. So we're going to do a cos and then a cos, and then a minus sine times another sine. And now we throw in the angles, 30 first and then 45. If we had written those in reverse order, it would not matter as long as we apply it consistently down here. 30, 45, and then another, that's a 30, and that's a 45. All right, and then to the unit circle. Cosine at 30, root 3 over 2. Multiply that by the cos at 45, that's going to be root 2 over 2. And then we minus sine at 30 degrees is a half times the cos at 45 is root 2 over 2. So our denominator, over here 2 times 2, over here 2 times 2, all ready to go. Common denominator is 4. Up top here, we get a root 6. And then a minus, 1 times root 2 is root 2. As with a lot of things in math, there's usually not just one way to get your right answer. When we're looking at this, the cos of 75, another way to rewrite that, instead of 30 plus 45, we could have done the cosine of 120 minus 45. That would also take us to 75. And then we could just use a different formula. We would use the cosine of a difference formula. And we would still get the exact same answer. It would boil down to this. I think if we did it this way, you'd get a negative root 2 plus 6 over 4. Negative root 2. Yeah, we just switch with the minus still is in front of the root 2. And if I remember right, that's what that remark in the corner is about. Yeah, just another way to get that 75 degrees. All right, here's a couple practice problems for you. Pause the video, try these out, see if you get the right answers. Notice the pi over 12, we already have the breakdown from that from example 1. And then 75, we have 2 ways to break that down from example 2. So the breakdowns, you can already flip back to those examples and check them out. Okay, cosine at pi over 12. Let me move this one out of the way for now. We're going to use the same root 3, pi over 3 minus pi over 4. So we'll use the cosine of a difference formula, and the cosine of a difference, that pattern is cos cos plus sine sine. Cos cos plus sine sine. And then our angles fall into place. Pi 3 first, quarter pi next, pi over 3, pi over 4. And then to the circle. Cosine pi over 3, that's a half, times cosine at pi over 4 is root 2 over 2, plus sine at a third pi is root 3 over 2. Sine at a quarter pi is root 2 over 2. Common denominator, yet again, will be a 4. This numerator will be a root 2 plus another root 6. And that's our exact value, cosine of 12 pi. And then we want the exact value sine 75. And I'm just going to do the sum formula again. The sine of 75 is the same as the sine of 30 plus 45. And the sign of a sum pattern is sine cos plus cosine. There we go. And in goes the angles, 30 first, 45 next, 30 and 45. And then to the circle. Sine, sine at 30 is a half, cos at 45, root 2 over 2, plus cos at 30, root 3 over 2, sine at 45, root 2 over 2. So our big old common denominator will be a 4 again. And then here we'll have a root 2 plus a root 6. And if you had done your angles backwards, 45 and 30, your numerator would just be flip-flopped root 6 plus root 2, but it doesn't matter what order we do the addition. Okay, example 3. They're asking us to find the exact value of sine of the sum. So we know we're going to use the sine of a sum formula. And they gave us two things. Sine of angle U is 4/5, where sine is between, angle U is between 0 and a half pi. That tells us what quadrant we're in. And then cosine of angle V is negative 12/13, and angle V is between half pi and 1 pi. So we're going to need to draw a couple triangles. And let's see here. I'm going to do a quick Cartesian plane. And I'm going to do my sine or my angle U stuff in red. So angle U is between 0 and a half pi. That means it's first quadrant. I'm going to draw my triangle going out into the first quadrant and back to the x-axis. And we're going to label that angle U. And sine is opposite over hypotenuse. So I know my opposite side is 4. And my hypotenuse is 5. That means my missing side is 3, since we know it's a 3, 4, 5 triangle. And all right, that triangle is set up. Angle V is between a half pi and 1 pi, so that's in quadrant 2. I'm going to draw my angle V going out into the second quadrant, always back to the x-axis. Cosine is adjacent over hypotenuse, so that will be 12 for adjacent. Hypotenuse is 13. And then which of those is the negative one? The hypotenuse is never negative, and think if we're graphing a point, if we're moving to the left of the origin, our x values are negative. Missing side here would be a 5, 12, 13, or if you don't have that one memorized, quick Pythagorean formula will get you that missing side. So now we get to use our formula, the sine of a sum. So the sine of a sum is, get back there, sine cos, that's supposed to be an S, sine cos plus cos sine. And our angles go in. U goes in first, and then a V, and then a U, and then a V. Now, some of this was the given stuff. Like here, sine of U is 4/5. Well, here's sine of U. We already know that's 4/5. And then we're going to multiply it by something here. We have cos of V. Cos of V is negative 12/13, and that's what we're going to multiply this by, negative 12/13. So this other side of the equation, we're going to need to go to our triangles. We don't know the cos of u yet, but here's u. Cosine is adjacent over hypotenuse. So that'll be 3/5 for cos u. We're going to multiply that by the sine of v over to the blue triangle. Sine is opposite over hypotenuse, 5/13. Now I'm just going to sneak up here for my final answer. Common denominator here, this side has a 5 times 13. This side also has a 5 times 13. So that'll be 65 as our common denominator. And then this numerator, if we multiply, we'll get a negative 48. And then we're going to add to that the other numerator, 3 times 5 is 15. Negative 48 plus 15 is negative 33/65. That is the answer to the exact value of the sine of that sum. Negative 33/65. Okay, I think there's a practice problem next. The triangles in the practice problem will be very similar to the ones here, not exact, but you will have a 3, 4, 5 and a 5, 12, 13. Make sure you get the proper side negative. And here's that huddle problem. Pause the video, try to solve it, fire it back up, and see if you got the right answer. Okay, I'm going to draw a little Cartesian plane here. I'll do red for u again. Angle u is between 0.5 pi, so that is in the first quadrant. Going to go out into the first quadrant, back to the x-axis. Sine is opposite over hypotenuse. Opposite is 12, hypotenuse is 13. The missing side is 5. It'll be positive because we're in quad 1. V is in quadrant 2, half pi to 1 pi. So this is V. I forgot to label that U. Cos of V. V is negative 3/5. Cos is adjacent over hypotenuse. Adjacent over hypotenuse. I'll make my adjacent side the 3 negative. So this is a 3, 4, 5. And if we're going up from the x-axis, 4 is positive. So there's our triangles. Okay, now we want sine of a sum, or excuse me, cos of a sum. So that pattern is cos, cos minus sine, sine. Oops. Cos, cos minus sine, sine. And here we just put in our u's and v's. U first, v second, u and v. Given information, sine of u, that's our 12/13. So that's right here, 12/13. The cos of v is negative 3/5. Here's our cos of v. So this is negative 3/5. And that's going to get multiplied by the cos of u. We're going to have to find that. Here's our triangle u. Cos is adjacent over hypotenuse. So that'll be 5/13. And then we're going to multiply that by sine v. Sine at triangle v here is opposite over hypotenuse, 4/5. So coming up here to the clear space, our denominators again, 5 times 13, 5 times 13, that's 65. And then this numerator will be a negative 15, and we're going to minus that. 12 times 4 is 48. Negative 15 minus is like adding a negative. So that becomes negative 63/65. Final answer. All right, here's the assignment. In class, we'll do some of these odd problems, time permitting. If you're working on the even problems to turn in and you're having trouble with an even, do the adjacent odd. 11 and 12 go together, 15, 16. They're paired up nicely. Do the odds. Remember, go to CalcView or CalcChat to see the solutions, and that'll help you with the evens.